Hello, everyone. Welcome to SECOORA's webinar series, Coastal Observing in Your Community. My name is Abby Wakely, SECOORA's Director of Communications, and I will be facilitating and moderating the webinar. SECOORA is hosting this webinar series to discuss, highlight, and raise awareness about coastal ocean observing activities in the Southeast U.S. and beyond. SECOORA is the regional coastal ocean observing system for North Carolina, South Carolina, Georgia, and Florida. We are one of 11 that make up the NOAA-led U.S. Integrated Ocean Observing System, also known as USIUS. Our mission is to sustain and promote observations that help keep you safe. This is a quick snapshot of the technology we support to accomplish our mission. I wanted to highlight SECOORA is soliciting proposals to fill at least 2 gaps and buoys operations on the East Coast of Florida. Proposals are due November 11th. Also, SECOORA has put together a page to highlight data and information related to Hurricane Ian. Together with partners, you can see SECOORA supports buoys directly in the path of the hurricane, and this page will be updated as new information becomes available. We are thinking of everyone who will be impacted by this major storm, and you can go to our news sections to find links to both these opportunities. Also, we have our next webinar on October 25th at noon. Everyone registered will receive a link to register for the Sargassum Watch from Space webinar. And let's get to the reason you are all here, the webinar. And so during the webinar today, we highly encourage you to ask questions for the presenter or technical questions for me by clicking the tablet-looking icon and typing your questions in. I will pose them to the presenter after their presentation. I want to remind everyone that the webinar is being recorded today, and we'll be posting it on the SECOORA website and sharing it with everybody who has joined us today. All right, so we are very excited to welcome Natalie Nelson, Megan Carr, and Nat Chaslow from North Carolina State University to present ShellBase, water quality data from shellfish harvest waters in one database. Natalie Nelson is an assistant professor in biological and agriculture engineering at North Carolina State University. Her research team takes a data-intensive and management-focused approach to the study of environmental system dynamics, with most of her projects focusing on water quality in estuarine and freshwater systems. Megan Carr, PhD student, and Nat Chaslow, MS student, will present some of their ongoing work in this talk. Megan is an alumni of University of Florida, where she received a BS in environmental engineering, and Nat is an alumni of NC State, where she received a BS in zoology and animal science. All right, Natalie, I am going to promote you to presenter, so you can go ahead and share your screen and start the webinar. So you should be getting the prompt right now.
Yes, perfect. All right. Okay, great. Well, thanks so much, Abby, for the introduction, and also a big thanks to SECOORA for inviting us to present today. So today I'm going to be talking about ShellBase, which is a water quality database that spans the shellfish waters of the South Atlantic states. And so to start, Abby already gave us an introduction, but just briefly, I'll ask my co-presenters to come off mute and say hi. So Nat, if you could please go first and just briefly introduce yourself, followed by Megan.
Yeah, hi everyone, I'm Nat. I'm a second-year master's student in the Department of Biological and Agricultural Engineering at NC State with Dr. Nelson's Biosystems Analytics Lab. And the work I'm presenting today was my first project I had started in the lab, so I'm super excited to go over it today. Hi everyone, I'm Megan. I am a third-year PhD student with Dr. Nelson. And ShellBase was one of my first projects I started in graduate school. So very excited that this is now at the stage of sharing it with all of you.
Great, thanks Nat and Megan. So also before I begin, I want to acknowledge others who are part of the ShellBase team who made ShellBase happen. So they include Jeremy Cothran, Dan Ramage, and Dr. Dwayne Porter, who are all at the University of South Carolina and were co-investigators on this work. And I should also mention up front that SECOORA, in addition to hosting the webinar today, had also provided the funding support for ShellBase. So first, I'll just briefly describe what ShellBase is. So ShellBase is a standardized database that integrates specifically fecal coliform observations from coastal waters where shellfish are harvested across the South Atlantic states. So this goes from North Carolina down through Florida. And although we're focused on the South Atlantic, it also includes the Gulf Coast of Florida. And so we have all of the data as well as really descriptive metadata describing the information and the context in which the data were collected on this SECOORA data portal. So I've included a link here to the data portal. And at the very end of the talk, I'll be reviewing basically step by step how you can go about accessing the data. So first, as part of this presentation, I'm going to zoom out and give you a bit of background in terms of how shellfish sanitation programs are collecting data and why we were motivated to integrate data that are collected across these different states into one database, into ShellBase. And then we're also going to present two different case studies, and that's where Nat and Megan will jump into the presentation. So they're going to offer some studies that they've been working on basically as a way of highlighting the opportunities of using this type of data to construct analyses and different types of decision support tools, but also to highlight some of the limitations of what can and can't be done with this data. So first, I'll address the motivation for creating ShellBase. And we're primarily motivated by the fact that when it comes to nationally coordinated programs for monitoring estuary and water quality, there are essentially few networks out there. And this is especially in stark contrast to networks that exist for freshwater monitoring programs. So here, for example, I have two maps of the contiguous United States. On the left, we have dots that are corresponding to all of the stations that fall within the USGS monitoring network, so specifically for water quality. And you can see here that there are about 13,500 stations. And of course, there's a really large land area in the US, but you can see that there's pretty good coverage then of many of at least the major water resources in the country. In contrast, if we look to the coast specifically, there are very few, like I said, nationally coordinated monitoring programs. So one of the few that we're aware of is the National Estuarine Research Reserve System's system-wide monitoring program, which they also refer to as SWAMP. And so as part of that monitoring program, there are 355 stations that are located across the coast. And so we have those mapped here on the right. And so although there are many more estuarine monitoring programs specific to water quality that are taking place across the country, they often tend to be a bit more locally specific. So there might be a program that's run by a local nonprofit or a state agency for a specific area, but when it comes to programs that have then nationally coordinated practices, there are very few. And so that's what we're highlighting here. And so when it comes to then looking for water quality data that has then some consistency in terms of the practices that are used to collect that information across the country, one potential source of information could come through state shellfish sanitation programs. So state shellfish sanitation programs are monitoring all waters where shellfish are harvested for human consumption, and in many areas that ends up resulting in having really dense spatial coverage of the coast. So to give you a sense for the differences then in terms of the amount of information available between these different monitoring networks, here on the left, for both maps, we're looking at the North Carolina coastline. And on the left, we have those National Estuarine Research Reserve swamp monitoring stations. So there are 4 stations that are located in the southern part of the state. But then if we look at the stations where the North Carolina Department of Environmental Quality is collecting data through their shellfish sanitation and recreational water quality program, you can see that there are stations that are essentially entirely covering much of the North Carolina coast. And so there are about 2,000 stations then where they either in the past have collected information or are currently collecting information. And for many of these sites, there are at least 20 years of data in North Carolina. So there are a lot of opportunities then to leverage this monitoring program that's managed through shellfish sanitation to then understand different types of trends in water quality across the coast and how things are changing. And shellfish sanitation programs are specifically monitoring fecal coliforms. So different monitoring programs might include different variables within their scopes. And so shellfish sanitation programs are going to be specifically focused on fecal coliforms, which are a class of fecal bacteria or fecally associated bacteria. And the shellfish sanitation programs, though, will sometimes collect other water quality variables, so things like salinity and temperature, but ultimately their main focus is on those fecal bacteria. And so why are they monitoring fecal coliforms or fecal bacteria? And the main reason is that they're ultimately charged with protecting public health as it relates to consuming shellfish that have been harvested from coastal waters. And so it's important to note that shellfish, so when I say shellfish, I'm really referring to bivalves like clams and oysters. They're filter feeders. So they're filtering from the water around them. And so here we have an illustration basically showing oysters or clams that are being cultivated through different mariculture practices, but they can also be harvested off of wild reefs. And so they're filter feeding, taking up the water around them to then consume algae as a food source. But through that filter feeding process, they can end up taking other types of things that are in the water, including fecal matter and then the bacteria that are associated with that fecal matter. And shellfish sanitation programs are specifically concerned with this from the perspective not really of the health of the shellfish directly, but instead the health of a person who would consume the shellfish that was harvested in waters where there may have been elevated fecal bacteria concentrations, because then that could lead to some pretty severe gastrointestinal illness. And so shellfish tend to be cultivated and harvested then in brackish waters, where they're receiving quite a bit of freshwater inputs from land. And we know that stormwater runoff tends to be the main driver of fecal bacteria in coastal waters. So basically, as you have rain that falls on the land surface and it starts to pool up and creates runoff that can then transport fecal matter from lands, like in backyards, for example, also just from wildlife and natural areas, and transport that to the coast. But then also following storms, you can have increased fecal bacteria due to there being higher likelihood of wastewater treatment plant failures, septic systems can be overwhelmed. So in coastal waters where shellfish are harvested, they're concerned about fecal bacteria concentrations, not only in baseline conditions, but also immediately following storm events. And so they monitor the water quality of these areas in order to understand how safe coastal waterways are for supporting shellfish that can be consumed by people. And so to mitigate some of these risks then associated with harvesting shellfish in areas that might be experiencing fecal contamination, shellfish sanitation programs are first going to designate different areas of the coast based on whether or not they are generally safe for harvest. So here, for example, we're looking at a map of part of the North Carolina coast. And so these different shapes that you see here, they have these straight lines, and some are also defined, the boundaries are defined by the coastline. These are different shellfish growing areas. And so each of these different growing areas is going to be assigned a harvest classification, such as approved for harvest or prohibited for harvest. And so in this case, for this stretch of the Albemarle-Pamlico Sound in North Carolina, the waters that are shown in blue are prohibited for harvest, and then these waters that are shown in this solid kind of tan color are those that have waters where shellfish can be harvested. And so to determine then these classifications, shellfish sanitation programs are taking in a range of information. They consider a lot of different sources of information, but a key source of information is from routine sampling data. So the shellfish sanitation programs will go through and collect data routinely throughout the year across these different growing areas to understand essentially what is that baseline water quality and are the fecal coliform levels such that safe harvest of shellfish can occur in these different areas. So areas that end up being prohibited, sometimes it's just for administrative reasons. So for example, in the northern part of the estuary here, there just isn't the administrative capacity to manage those waters. But then in other areas, for example, here further south in the Sound, a lot of times the upstream waters will be prohibited because they just receive too much freshwater input or they're in too close a proximity to potential pollutant sources like wastewater treatment plants and marinas. But then they will use the routine sampling data to help inform this classification. And so in waters that are approved, those are areas where, based on the range of information, including routine sampling data, they've determined that shellfish can be harvested safely from those waters. But I had mentioned previously that there's also concern in some areas that immediately following storms, you could have an increased likelihood of there being higher fecal bacteria concentrations in coastal waters. So some states, not all, will have an additional classification referred to as conditionally approved. And conditionally approved is essentially what it sounds like. The waters are approved for harvest, but with conditions. And those conditions are that it can't have rained over a certain amount within the day prior. And so here, for example, we've just moved down the North Carolina coast. We're a little bit further south now. And these are, again, the different shellfish growing areas, these polygons that you see here. But in this case, these are all conditionally approved shellfish growing areas. And the color is corresponding to a rainfall threshold, which is shown here in this legend. So the darker the color, the lower the rainfall threshold. And so here, for example, on the Newport River, you see these polygons that are shown in red. These are shellfish waters where if there's an inch of rainfall that falls within a 24-hour period, those waters will be temporarily closed for harvest. So conditionally approved areas will experience then these temporary closures as a function of rainfall. And that's at least the case in North Carolina. This varies a bit state by state. And so once one of these waters has been temporarily closed, in order to reopen the waterway, the Shellfish Sanitation Program is going to go out and collect samples to see if water quality has returned to a safe concentration of fecal coliforms. And so we refer to this type of sampling as conditional sampling. And so whereas routine sampling occurs throughout the year to basically characterize the baseline water quality conditions of an area, conditional sampling is done for the purpose of reopening. And this is not just a routine monitoring type of data collection system, but it's instead in response to one of these closures having occurred. And so there is variation then across the states, as I was just alluding to. So all shellfish sanitation programs in the US fall under the US FDA's National Shellfish Sanitation Program, which offers then specific criteria in terms of how their monitoring programs, including their random monitoring and also their conditional sampling programs, how those should be conducted. But then states have some flexibility within those guidelines to then implement those practices based on the conditions in their state and also the administrative resources available. So here, for example, we have a table that is showing across each of the rows, we have different characteristics then of shellfish sanitation programs and the data that they collect. And the columns here are corresponding to 3 different states, so North Carolina, Georgia, and Florida. And what I want to highlight here is just how there can be then differences in the way that data are collected across the different states. So here we have routine monitoring strategy, for example. And so Megan will touch on this when she presents her case study, but North Carolina and Georgia use what's called a systematic random sampling approach, whereas Florida uses adverse pollution conditions sampling. They sample at different frequencies. So in North Carolina, each of those growing areas will be sampled 6 times annually. Georgia does monthly, and Florida will do monthly to quarterly. And then the conditional sampling criteria can also vary. So I had described this rainfall-based approach that we use in North Carolina, so that would be a rainfall threshold, while in Florida they also consider river stage, and then in Georgia they don't have conditionally approved areas, so they don't have conditional sampling. So there are then these nationally coordinated practices, but they end up having variation between the different states. And so to summarize, shellfish sanitation data we think offer a lot of value for a few reasons. The first is that although there is variation across the states, the practices are nationally coordinated through that National Shellfish Sanitation Program, and so that creates structure then through which you can understand the data across the different states. And the data typically span decades, so they have really impressive long-term records, and they often have high spatial resolution that you can't find in other coastal monitoring networks specifically for water quality. But the use of these data and analyses and for developing different types of model-based tools is complicated by the fact that you have differences in management criteria. So for example, there can be restrictions as to when routine sampling data is collected, and that can lead to routine sampling data not being comparable between the different states. And also the data types and structure are going to vary state by state to reflect that diversity and how the programs are run. And so in this case with ShellBase, we're trying to then eliminate some of the barriers to using these data because we think that they could offer a lot of value in terms of understanding coastal systems and how they've changed over time. But there's nothing we can do about the fact that there are differences in management criteria, and also that the management criteria in some cases have changed over time. But what we could do as a research team is work to make the data integrated and more accessible. So we're trying to overcome then this barrier that I've listed here. And so that's what we've done with ShellBase. And so ShellBase is integrating data from programs that have different styles of data collection and organization. So here, for example, we see snapshots of 2 different spreadsheets from data that were collected by the Shellfish sanitation programs. And you can see that they're organized very nicely, but in very different ways. And they sometimes have different variables that they've included. So what we've done with ShellBase is we've created an integrated database structure that has the exact same organization. And even if the states have differences in the variables they collect and different practices, we're able to still have the same organization across the states. And so within the ShellBase metadata posted on the SECOORA data portal, we describe that structure in more detail. But the main takeaway you should have from this is that although the states are different, the way the data is presented in ShellBase is consistent. And so now we'll present 2 different case studies demonstrating how ShellBase data can be used to analyze long-term water quality trends and also develop predictive decision support tools. So I'll go ahead and pass the torch to Nat Chazelle.
Yeah, thank you. So this first case study involves using ShellBase data to analyze long-term water quality trends in North Carolina's shellfish growing areas. So the focus of this project in particular is looking at the past 20 years of fecal coliform trends in North Carolina's estuarine shellfish growing waters and contextualizing those trends within their respective management and ecological landscapes. So we broke this down into 3 main objectives. The first being to assess whether we can actually use this monitoring data to infer anything about water quality, to analyze the fecal coliform concentrations over space and time, and to identify any possible management or environmental relationships to these fecal coliform trends that would indicate drivers of change within these study systems. So for our study system in particular, we took all almost 2,000 water quality sampling stations along North Carolina's coast, as seen in the black and orange points on this map. And we filtered out stations based off of data quantity. So because we were looking at long-term trends, we only took stations that had 20 years of continuous data between 1999 and 2021. And when we say continuous, that just means that there was at least 1 sample taken during the year, but because we aggregated annually to come up with a mean fecal coliform estimate. But because the national standards for North Carolina's sampling strategy require at least 6 samples to be taken for classification purposes, there were usually at least this number of samples for these stations. So this produced 466 stations that you can see in orange on the map on the right. And so those were the stations that we used in this analysis. So as for methodologies, because this is a time series with fairly regular data, we were able to use Mann-Kendall trend testing, which is basically a statistical test that will measure the strength and direction of a one-way or monotonic trend using a tau statistic. So this tau value ranges from -1 to +1, with positive values indicating an increasing trend and negative values indicating a decreasing trend. So for example, a value of a tau of 1 would indicate a perfectly increasing trend, with each consecutive point being larger than the last, as you can see in the blue line in this little example graph. However, as the number of inversions in the data increase, the tau value will decrease. So the black line that represents the actual data that we would see have a lower tau value than the blue line. But because there is an evident trend, even if it is noisy, the tau value will still be positive. So this is great because it tells us if there's an actual trend in the time series. But to be more informative, we need to use send slope testing to measure the slope or magnitude of that trend that we're measuring. So this test provides us with a beta value that would represent basically the average slope of the data. And you can kind of see the slope of the blue line. So now with this tau value, we have whether or not there is an actual trend and the magnitude of that change represented by the beta value. So this is a map of the results of this analysis. The sampling stations are colored by the tau value, with the red indicating a positive tau value, meaning an increase in the 20-year fecal coliform concentrations. And the blue and green indicate a negative tau value, meaning a decrease in the fecal coliform concentrations over the past 20 years of sampling. So the stations are also sized by the magnitude of the send slope. So the larger points are increasing or decreasing at higher rates. The inset map is just there to give you a better look at a specific area results in Carteret County, North Carolina. You can see that there are some patterns cropping up. There are clusters of blue and clusters of red in these trends along our coastline. And to get a fuller picture of these values, we need to contextualize these trends. So to try and capture that sort of local nuance in the interpretation of fecal coliform trends in relation to their environmental parameters, we chose 3 focal areas to focus in on to get a representative sample of different ecological and maricultural landscapes that we can interpret. So we define these areas based on estuarian type, rainfall threshold, developed land change, and leasing activity, all labeled on the left. So we have B in the bottom left, or area B in the bottom left, which is characterized mainly by the Cape Fear River that carries waters from this highly developed Wilmington area south to the Cape. So the relationship that you see farther south with the increasing fecal coliforms, that those clusters of red dots associated with this high intensity development tracks with what we expect from a system like this. So focal area E in the middle experiences a more mild but still moderate increase in development, but you can see that a majority of the points in that area are green and blue, indicating a 20-year decrease in fecal coliforms. So this inverse relationship may be due to some constraints and management factors, meaning that the data set contains samples from areas where the rainfall thresholds have changed over time, and therefore the times in which management can sample have also changed over time, making the interpretation a bit more complex when it comes to doing this generic type of trend testing. Therefore, we need to sort of put more careful thought into the interpretation of these results. And then lastly, area G at the top has the least amount of management constraints, and with the low level of development, may be the most representative of fecal coliform dynamics in this type of area. So that was a lot of information. But the main takeaways from this study were that this ShellBase data can be used for long-term water quality inference, but sampling strategy needs to be taken into account when drawing conclusions, because certain type of management strategies that work for day-to-day management may start to bias the data for this type of trend testing. But even though trend results from management areas with thresholds that have changed over time can't be used for inferring long-term fecal coliform trends, those results can still be used to demonstrate the effectiveness of the current and past management decisions in a particular area. So again, I would like to stress that this type of study has not only been enriched, but would not have been possible without the engagement of local experts, especially from the Department of Environmental Quality, giving their interpretations of these results based off of their understanding of how they collect, analyze, and interpret the data themselves. And a specific shout out to Andy Haynes in Moorhead. I think you're on. Thank you so much. And that's all I have. Thank you.
Thanks, Nat. Next, I'll speak on case study number 2, which is using ShellBase data to develop predictive decision support tools. In this project, we use shell-based data to develop decision support tools to inform shellfish growing area closures and reopening actions. And the objectives for this project were to first develop data-driven models suitable for administrative decision-making, and then second, to assess how the type of routine sampling affects the model dataset and the model's predictive ability. So to begin this project of how to use shell-based data, which spans the entire coast, our first question was to determine what sort of system and at what scale we wanted to develop our decision support tool. Ultimately, we decided upon the watershed scale because using HUC 12s, HUC 10s, we're able to scale that up to the entire coast while still maintaining some local dynamics within the subtributary and tributary scale. And then we were able, based on kind of deciding that, we formed 3 questions to help us kind of narrow down what predictors we wanted. And so based on question 1, what are the watershed sources of fecal coliform? Question 2, how are fecal coliform transported from the watershed to the shellfish growing areas? And then question 3, how can we affect what can affect fecal coliform concentration in the shellfish growing area? So these 3 questions kind of helped us develop the pool of predictors we could use to estimate fecal coliform concentration, and then based on that concentration, what management actions should be taken, whether closures or reopenings. And with those kind of ideas, so we have the watershed scale we're looking at. We also wanted to add a few more criteria for our predictors. So the model that we developed would be fit for administrative use. And so the first criteria was that the spatial scale of our predictors needed to match the spatial scale of ShellBase. And this is important because a lot of the state sanitation programs manage the entire coast of their state. So we wanted to develop a model that was fit for their administrative needs for that. And then secondly, we put in the criteria that the data must be publicly available and quick to obtain. And this was because we wanted to develop a desktop use model where going out to collect additional data from fieldwork was unnecessary, that they could pull what they needed from the internet, from recent rainfall, and then run the model. And so with those 2 kind of thoughts, watershed, criteria to administration, we developed a list of potential model variables which could estimate either fecal coliform concentration or fecal coliform risk class, whether exceedance or no exceedance, based on what was occurring in the watershed. So as you can see here, we split up our list of predictors to correspond to those 3 questions which I listed. So we have a set of predictors which represent how the phenomena on where fecal coliform can be transported from the watershed to the shellfish growing areas through rainfall, wind speed, river stage, and so on. We also have a set of predictors which is representative to potential sources of fecal coliform in the watershed, such as total watershed area, the land cover of that watershed, and then the soil within that watershed. And lastly, we have a few predictors which are representative of the dynamics within the shellfish growing area at the time that the samples were collected. And so with our list of predictors, which are representative of estimating fecal coliform, we needed to take a further look at the fecal coliform data set, which we obtained from ShellBase. And so the data set of the fecal coliforms are constructed depending on the sampling protocols that the state programs use. And so the 2 sampling protocols, which the National Shellfish Sanitation Program sets forth, are 1, systematic random sampling, and 2, adverse pollution condition sampling. And in systematic random sampling, water quality samples are collected with the intent of capturing everyday conditions. So everyday conditions, you can more or less think of, if I were to go out to Carteret County and see the sound, what would it most likely be? And so normally it's not huge rainstorms, it's not huge river discharges, it may be light rain or like a sunny day. And so when collecting over time with that preference, ultimately the data set which is constructed is also preferentially going to contain fewer extreme weather observations. And so this has an effect on, if you go to model, what sort of relationships will be developed within that model. So for systematic random sampling, because there's this preference for fewer extreme weather conditions, for the sake of having average day conditions, the relationships that you're most likely going to develop from this statistical model are going to be average day relationships. And this is in comparison to adverse pollution condition sampling, where water quality samples attempt to capture the worst case conditions. So that's a strong word, worst case, but essentially what that means is, was a rainstorm, a large rainstorm moving through the area? Were there like high discharges? So this is collecting samples when you expect fecal coliform at higher concentrations. And because of this, over time, the data set that you're going to develop from adverse pollution condition sampling, it's going to preferentially contain more extreme weather observations than in comparison to systematic random sampling. And because of that, the model data set and the model that you develop, it can consider relationships with worst case conditions because you're including more observations of that within your data set. And so now looking at using these data sets for conditional leases. So what Natalie touched on previously, a big portion of what coastal managers will do is when rain or high river stages come through, they have set thresholds to initiate closures and meaning to reopening. So we saw a great fit for using ShellBase for helping them make those coastal management decisions. However, depending on the data set of the routine monitoring, it's going to affect the end use of that model. So in North Carolina, which employs systematic random sampling, it's going to have that data set in the model of typically developing average day conditions. And for this, if we're considering whether it's best fit for closures or reopenings, we can consider what the water quality is going to be at the time of closures and at the time of reopenings. So for systematic random sampling and this preference for average day relationships, this is best fit for the model to predict when a reopening sampling should be initiated. So this is the best fit use for administrative tasks. However, moving into kind of the results of this model and then this data set, we found that we weren't able to predict continuous concentrations well. So having a concentration of exactly 17 NPN per 100 milliliters. Instead, this model was, we ended up having it to predict categories, whether or not the exceedance or no exceedance was occurred above the regulatory threshold. And we found that having our model predict kind of risk class categories was a way better fit, and we produced higher accuracy in comparison to just predicting fecal coliform concentrations. And so this is in comparison to the model we developed with the Florida ShellBase data, which this data set was constructed using adverse pollution condition sampling, which, as a reminder, is the sampling which prefers kind of the worst case scenarios. And very similar to the thought process and the decision process of the objective for the North Carolina model, we considered the water quality of potentially worst case scenarios. What is this best fit for the administrative tasks? And we decided that it was best fit for closures, because during closures, which are activated because of high rainfall or high river stages, this is kind of more towards, again, the worst case end of the water quality spectrum. And because our data set preferentially has those sorts of observations, we determined that this model for the Florida data was best used for predicting the closure of a growing area, compared to the North Carolina model, which was best fit for predicting when to initiate the reopening process. And results-wise, we found out that the Florida model did predict concentrations well, as evidenced by the figure here on the right. So we have very high R-squares in most of the watershed areas of Florida, which is not something we were able to see for the North Carolina model. So in conclusion for this case study number 2, we found that shell-based data can be used for creating predictive decision support tools, particularly when you use it in the context of having predictors of the watershed scale and then meteorological predictors such as rain, that we can reasonably predict fecal coliforms with good accuracy. However, I am definitely stressing that the sampling strategy used for routine monitoring will affect the use and resolution of the model you end up developing, whether the use of the models for predicting closures or reopening, and whether that model is capable of predicting continuous values, or if you need to move to a more categorical prediction.
All right, thank you so much, Nat and Megan, for presenting those case studies. And so again, the intention with sharing the case studies is to demonstrate how the data can be used to gain insights and develop tools, but also how the interpretations and the use of the data are limited based on the way in which the data are collected, whether it's the sampling strategy or it's the management criteria, such as the rainfall thresholds that can ultimately dictate when the routine sampling data can be collected. And so now returning to ShellBase and how to access the data. So if you're interested in using these data for different applications of relevance to your work, you can find the data by, again, going to the SECOORA data portal, and I have that link here. And so if you go and search for ShellBase in the data catalog, you should be able to see the data on a map, and here then is the page specifically for ShellBase. And so a few things that I want to highlight about accessing the data is, first, when you arrive on the page for ShellBase, you'll see that the title explains that the data have information for Florida, Georgia, South Carolina, and North Carolina from the 1980s through 2020. And so at the top of the page, we have some descriptive information about ShellBase, and the metadata URL here will then take you to additional descriptive information about how the data were organized, and also just contextual information about how the data were collected. And so you'll then scroll down, and although we've structured ShellBase so that the data are organized consistently across all of the states, we chose to publish the data not as just one spreadsheet that you would access, but instead separate spreadsheets for each of the 4 states. And that's basically in response to feedback we received from the states. So because there are then these differences across the state programs, it's important to not do direct state-to-state comparisons with the information, because the data cannot be compared as apples to apples. And so to reflect this concern about not performing analyses that would do state-to-state comparisons, we've published the data separately for each of the states, but again, the data are organized the same way, so tools and analysis scripts that you produce for one state could then be applied to another state without doing those interstate comparisons. And so if you scroll down on this page, you'll see data download options for each of the 4 states, and you'll also see data citations and additional metadata information for the states. And so if you click on then the download button that corresponds to each of the states, each time you click the downloads button, there will be a new window that opens up. So here, for example, this is the data download page specifically for South Carolina. And there are many different options, including downloading images like of what you see on the map on the SECOORA data portal. But the file that is going to be of most interest to those of you who actually want to work with the data directly is this comma-separated values file. So that's going to be the spreadsheet data. And you can download that by clicking on the green button. And if you're interested in knowing much more of the detail in terms of how ShellBase was constructed, you can refer to an article that we recently published in Aquaculture Reports, and it's open access, so you should be able to download it for free. And so it's called Implementing Fair Data Management Practices in Shellfish Sanitation. So in this article, we not only describe ShellBase, the motivation for ShellBase, and also provide details in terms of how the data are organized, but we also offer some recommendations as to how shellfish sanitation data can be more findable, accessible, interoperable, and reusable. So that's the FAIR acronym in the title. And before closing, I wanted to give a big thanks to our sponsor, SECOORA, and also our many collaborators. So in order to construct ShellBase, it required many different meetings with the state shellfish sanitation programs, who taught us a lot about the way their programs were structured, how to interpret the information in the data, and they offered a lot of really invaluable feedback throughout the entire process. And so I have the names of the people who we've been meeting with here, and we also had been meeting with Keith Skiles from the Interstate Shellfish Sanitation Conference, who also provided us with a lot of big scale vision in terms of how shellfish sanitation data inform different types of policy making and management. I also want to specifically thank our collaborators on the case studies, including Andy Haynes, who Nat had already mentioned previously, who's been a huge help to us, as well as Dr. A.K. Light at NOAA. And then the others on the ShellBase team, Jeremy Cothran, Dan Ramage, and Dr. Dwayne Porter, who made ShellBase a reality, in addition to Megan, who had done a lot of that initial data work to get all the information into ShellBase. So we'll now go ahead and transition into the Q&A period, but I also just wanted to mention that we have here our email addresses for those of you who might want to follow up with questions afterwards. You can also learn more about the work we do in my research lab by going to the website for our lab at go.ncsu.edu/nnelson. And thank you so much for your attention and attending today, and we're happy to take any questions you have.
Great, thanks so much, Natalie. So if you guys have questions, you can put it in the Q&A chat and I'll ask Natalie. I'm not seeing any right now, but I do have a question for you. What are the next steps for ShellBase? I know it goes to 2020. Is there any hope to get more funding to do something else with ShellBase and all that great data that you guys organized?
Yeah, great question. Thanks, Abby. So in terms of additional funding, we do have a little bit of support through a grant that has been issued through SECOORA to Dr. Dwayne Porter and his team, through which we're basically looking to expand some existing decision support tools for different water quality, basically different water quality predictions. So we have Shellcast, How's the Beach, and then also the beach condition reporting system that we're expanding across the South Atlantic through that project. And through those efforts, there will be a little bit of updating to ShellBase, although there aren't any funds in line right now to do some long-term maintenance. So that is something where we'd be really interested in speaking to anyone who'd be willing to support some longer-term maintenance of ShellBase.
Great, thanks so much, Natalie. All right, so I'm not seeing any questions. If you guys need a reminder, it's the little tablet looking icon. And I did share a news story. I'll share it again. All right. Natalie, can I post your email in the chat? Is that okay?
Oh, yeah. You can post all our email addresses. Can I, if I drop them in?
I think you should be able to drop them in.
It looks like I think I can only send it to the organizers, but I'll go ahead and do that now.
Okay. And then Astrid has asked or said, what an amazing database. Are there potential plans to use the platform for additional pathogens?
Ooh, great question, Astrid. So for right now, as far as I understand, but I think there are people from shellfish sanitation programs on the line, so they'd be better suited to address this directly. But I don't believe that data outside of fecal coliforms are routinely monitored by the state shellfish sanitation program. So the structure of ShellBase is such that it would be very easy to add additional variables, like additional types of potentially pathogenic bacteria, or I mean, really anything, any sort of water quality variable. So it was designed in such a way that it would be easy to add additional covariates. We don't have plans right now, but Astrid, if you have ideas, I'd love to hear them.
Great, thanks so much, Natalie. And this is from Charles. Any interest in doing this type of work / analysis in the Gulf?
Oh yeah, absolutely. Yeah, so for right now, we've just been focusing on the states that we've immediately engaged in this work. But if there are other states that similarly would like to do this type of thing to either have ShellBase or expand into the decision support tools and analyses that we presented, I'd be happy to speak further.
Great. So I will, Charles, send also the emails to you as well, and you guys can connect. And I also put them in the chat. And we have another question from Duncan. Do you know if the data contained in this database is also being housed in the National Water Quality Monitoring Council, which is the federal data repository?
Yeah, that's a great question. So as part of that article that I mentioned at the end, one of the recommendations we offered is that we think it would be ideal to archive to such a portal. Right now, as far as I understand, I don't think that the data are being archived there, although it's possible in Georgia they may have been doing something like that. I'd have to go back and check my notes. But I believe that because the shellfish sanitation programs fall under the FDA and not the EPA, there isn't that same type of mandate to archive through the National Water Quality Portal, the way you'll see other programs like recreational water quality programs archiving. So currently those data from the shellfish sanitation programs are for the most part not available through the National Water Quality Portal.
Great, thanks, Natalie. All right, I'm not seeing any more questions, but these have been great questions so far. And I'll add the link to our data portal also in the chat, and you guys can just type in ShellBase in the catalog and you should be able to find it. And then it's also available in that news story that has been shared. So we'll just give it one more minute to see if there's any more questions that come in. My cat really wants to join the call here. And I want to thank you guys all for joining us, especially those from Florida who are going to be impacted by the hurricane. We are all thinking of you. All right, so I'm not seeing any more questions. So I think we can end a little bit early. And I want to thank you, Megan, Nat, and Natalie, for your time today. And the webinar has been recorded, so we will share the presentation with everyone and the recording. And I appreciate you guys taking your lunch hour with us. All right,
yeah,
thanks
so much, everyone. Take care. Bye.
Have a good one. Bye-bye.